Assalamualaikum warahmatullahi wabarakatuh. Our selected topics is real-time with low distributed routing protocol in wireless sensor network. We will analyze deadlock and mutual exclusion as concurrency problem and solutions using case studies found in articles, which will enable to enhance our understanding of multi-threading in process. This section covers the restricted top-level domain, which is designed for real-time routing in wireless sensor networks. In general, the results show that RTLD performs well in the term of the delivery ration, power consumption, and packet overhead. This is owing to its forwarding method, which takes into account the issue of real-time routing protocols.
For our group, the concurrency programming and problem solution is two CP problem is deadlock and the mutual exclusion. For the deadlock, we have a problem because of the shared resources and inefficient execution order of processes. There are two solutions for the deadlock part, which are PatriNet model, which is a method to focus on the concurrency synchronization and conflict situations in FMS, and another solution is resource allocation system to ensure the resource to sharing effectively. For the mutual exclusion is to prevent race conditions, in which it is to make sure one execution thread will never enter the critical session if there is a concurrent execution thread that has entered the critical session, where critical session defines the time interval taken by the execution thread when accessing a resource.
Hello, this is MOHSIN SHAIKH, and today I am here to present RTOs. So we have three RTOs for our system. The first one is free RTOs. Free RTOs is one of the well-known embedded system in market, which is chosen in the XNOR development, in which it brings some benefits including open source, applying C programming language portable, advanced configurability, providing commercial support free of charge, and huge community of users. So the next one is RTOs based on image recognition. This project is based on an intelligent human recognition system based on ARM7 embedded processing technology of digital videos, image identification technology, GSM wireless mobile telecommunication technology, GPS positioning technique. So this project will actually use image recognition and also use GPS. So the third one is RLRTX. RLRTX is a remote measurement and control system based on ARM with RLRTX. Remote measurement system is one of the embedded system which is designed for the purpose of the adapting to the limited performance of the processor security level and storage space. That's all. Thank you.
Hi, so now we share our group discussion for this project too. So for the concurrent programming problem that we discussed before, we found one problem that occur in our project one, the contact tracing system. The problem is a deadlock where in our project, we have the two processes, tracker and radar process, which both of the processes use the same resource, which they need to wait for each other before they can use the resource they want. Deadlock happen in that situation. Other than that, after comparing the three RTOS system, we have come to certain the best suitable answer for our project one, which is the system RTOS based on image processing. This is because the possible justification could be that it uses GPS camera while the Bluetooth is not in it, but there's a point for us to include in such a system of a perfect suit of our project. That's all.
So, we would like to conclude our project by mentioning that after certain reviewing of the papers, we have come to an end discussion and decision to improve our project is that we have decided for the CP problem we are going to see. Deadlock is one of the CP problem we found in our project, and resource allocation system, which is a system to process and allocate the available resource effectively. And for the RTOS solution, we come across the best and the suitable is the RTOS based on the image processing. So that was the best reach according to the paper's review and our effort to improve our project one and make it good and better. Thank you and have a good day.